Hey. All right, so now we are going to actually do a little bit of graphing, just really, really quick. Our graphing is going to be based off of this equation here. Y is equal to 2x, well, not plus 4, but minus 4. Okay, 2x minus 4. Our focus with this is going to be twofold. One, we are going to find a bunch of ordered pairs that we can use to graph this equation, and two, we're going to actually graph it. So I highly, highly suggest for a while that we create a T-chart. And this T-chart isn't quite a T-chart, it's like a double T-chart. It is going to look like this, where I have x, y equals 2x minus 4, and y. So we've talked about the fact that we are going to start going to two variable equations. And we already know based on our last module how to evaluate expressions if we have a point or if we have a value. So we were looking at this sort of thing where we said 2x plus 3, what if x equals -1? What does this equation look like if that's the case? I'm going to put this -1 in for x, and we would say 2 times -1 plus 3, and we'd simplify that. 2 times -1 gets me -2 plus 3 equals a +1. And we can handle that. Now we have a two-variable equation, meaning I have to put numbers in for my input into this equation, and I will evaluate this. And after I evaluate this with my new input, I will come up with an output that I then put here, which then gives me a coordinate pair. So let's look around and see what that actually means, and then let's try to graph these things. So we have x. I always pick these 5 numbers. There's a reason why I'm this side of the screen, by the way, because I'm going to put a graph up behind me pretty soon. All right, so on this side of the screen, I always pick these same 5 numbers. These are my 5 numbers that I always pick. -2, -1, 0, 1, 2. Why do I pick these particular numbers? Because negative numbers, it's important to see the behavior of an equation given negative numbers. It's always important to see what happens when x equals 0 in any situation. And it's important to have a couple of positive numbers. You will see a lot of interesting behavior if you have any equation that you can put those numbers into. As well, I also know that I can easily shift to more negative numbers if I need to, and I can easily shift and get more positive numbers if I need to. So this is just always a nice starting place because I have negative numbers, I have 0, and I have positive numbers. So now I'm going to put these values that are in this x column into this equation and evaluate it for its corresponding y. So I'm going to put this in for the input into this equation, evaluate it, and get an output. So it's going to look something like this. Y is equal to 2 times -2 minus 4. And I'm going to rewrite my equation with its new input of a -2, where the x was. So now I can evaluate this. 2 times -2, that's where I have to start. Multiplication happens before subtraction. 2 times -2 is -4. Minus 4 gets me -8. So now what I have here is I have an x, y coordinate. So my new point for this situation is -2, -8. That is a point on this graph of this line. Now I'm going to put -1 into this equation and do the same thing, and I'm going to do it for all of these values. Y is equal to 2 times -1 minus 4. -2 times 2 times -1 is -2. Minus 4 is -6. Another ordered pair, -1, -6. I'm going to put 0 in there. Y is equal to 2 times 0 minus 4. 2 times 0 is 0. Minus 4 is -4. 0, -4 is my next coordinate pair. I'm going to do the same thing. Y is equal to 2 times 1 minus 4. 2 times 1 is 2. Minus 4 is -2. And hopefully you are starting to see a pattern with these outputs. Every single value that I put in here ends up being a nice pattern here. And you should see a pattern of plus 2 from the number before. Yeah, so we can predict what this last number is going to be. If this is plus 2 each time, negative 2 plus 2 gets me 0. So let's see if my prediction is accurate. I'm going to put 2 in for my x value. 2 times 2 is 4, minus 4 equals 0. Cool. So here's my final coordinate pair, 2, 0. So now what I'm going to do is I'm going to graph these coordinate pairs. I may have to erase my table. So if you don't have this table written down, if you haven't played around with this, please make sure you pause this video and copy this down so you have it all in your notes. This concept of this like double T-chart is really important for showing your work really, really well. Okay, so pause the video. All right, if you don't need to, let's graph. All right, so we can kind of see it. All right, so here's my graphing paper. I am going to put all of these coordinate values on this graph. Now remember, our coordinate pairs always are graphed x value first and then the y value. And our x value is this horizontal line. The y value is this vertical line. So I need to find where x is negative 2. If I'm starting here at 0, here's negative 1, here's negative 2, and now I need to go down 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And that's my point, negative 2, negative 8. I'm now going to graph a couple more, like all the rest of these. Negative 1 from 0 to negative 1, down 1, 2, 3, 4, 5, 6. That's my value, negative 1, negative 6. 0, 4, 0, negative 4. I'm at 0 for my x value. Now down 4, 1, 2, 3, 4. 0, negative 4. 1. I now get to go positive with my x values. Down negative 2, 1, negative 2. My last one, 2, 0. Over 1, 2, 0, 2, 0. And now I have all these dots that are graphed here, and I can connect them to form a line. Now with my graphs, a few things. I'm always going to graph at least 5 points when I am doing a T-chart, and I expect you to do the same thing. So I want to see 5 points always graphed. And number 2, I want you to make sure you're drawing your arrow so it fills up as much of the graph paper as you possibly can, and you're putting arrows on the ends. So to sum this up, I want to always see 5 points graphed. 2, I want to see the line fill the graph. And 3, draw arrows. Those arrows matter because they imply that this graph, this line goes on forever. And that's really important because this equation doesn't have any limits on it. It's not saying like you only go from this point to this point. It's just this equation, which means it goes on forever. So we have one more video after this. It's one more example problem. If you feel good about this and you want to try this on your own, you can start working on the must-do problems from here. The next video is a little bit optional and is only if you need to see this happen again in another example problem. Okay? See you in the next video or see you in the classroom. Bye.